Hello, and welcome to the Adafruit Show and Tell. I am Melissa, and I will be your host tonight. And I'm going to go ahead and put Scott on first.
Hello, thank you for hosting.
Thanks.
So, I am currently a jumperless breadboard, as you can see.
Your mic's a little bit quiet.
Is it still quiet?
Yeah.
Let's see. Let me see here. Sometimes Is that better? Better?
I'm still having trouble hearing you.
Okay. Maybe I'm on the wrong mic. Do you want to come back to me?
That sounds better, actually.
Okay, I'm looking straight, so we'll try to look straight. So this here is a jumperless breadboard. So it's a half-size breadboard where the connections are actually made programmatically via this giant matrix of analog muxes. And I'm like notorious, like I really avoid doing breadboarding stuff because I'm super lazy about it. Partly because I have to like dig out all my stuff, but then also I have to figure out how to wire it all up. So I'm just going to plug it in. And one thing that's cool is that it has LEDs under every spot on the breadboard. And if this looks a little better, I can do that as well. So that's just like the LED plastic on top. So I'm working to get to this world where I don't have to like think about how to breadboard things. So on my screen, you can see I had this new breadboard command that I've been working on. And I can hit Fritz, and it looks up the fritzing files and figures out how to connect it up. So it's automatically determined where to place the two components that I asked it to like connect up, and figured out like what breadboard rows they are and how to connect them. And then I can do a different command called jump. And what this is going to do is it's going to set me up on the jumper list. So it has lit up the LEDs where I need to place my components. So I'll just go in here and place them. It should, I think it does an extra step, but it should show me the fritzing here to make sure that I put it where I thought I would. And then it say, okay, are you ready to connect everything up? And once I say yes, it now loads up and connects the breadboard rows together for me. And the jumper list has now like drawn the wires. I'm doing air quotes, you can't see me, but they've drawn the wires on here to connect it all together. And it also can do automatic like serial and UART and ground linking as well, which I'm still working on perfecting, but this is how far I've gotten. Getting a world where it can just put it on a breadboard for me, and then also I'm imagining being able to automatically generate like Python test code to run in CircuitPython for a given pinout that this thing's decided. So no, I will no longer have to worry about the pinouts of things. I'll just be able to say, hey, I want to test with this I2C sensor and this board, make it so, and it will figure it out for me. So that's been my side quest.
Cool. Thank you for showing that. That's pretty cool. So the audio muxes, that's pretty interesting way of doing that there. So it's like basically it makes a solid connection through there.
Right, yeah, a bunch of analog muxes. Yep, and you can get this off Crowd Supply. It is not cheap, but I'm also imagining worlds where we could like test every pin, right? So CircuitPython tries to know like every pin that can do a particular thing. Like having this in loop to test that would be cool.
It's pretty cool. Well, thank you for sharing it.
Thanks for hosting, Melissa.
Yeah. Let's see. I think next we're going to have Erin come on here.
Hello.
Hi.
Hi. So I'm working on kind of a silly, fun project this week. I have made a head in a jar. and it's got a circuit playground underneath. And when you tap on it, let's see if it'll work for me today. Then he actually blows some bubbles, which is pretty fun. So I'm working on a tutorial for this week, and I'm gonna show how to make like the file for the head. This is actually a friend of mine with an actual fake mustache in there to try and hold some of hide some of the bubble equipment, and some lights, and show how to make it tap sensitive with the circuit playground underneath. I've still got a couple little leaks and stuff, so it's still prototype phase, but I should be writing the tutorial this week.
That's pretty cool. So how did you make that the face on there then?
So it is, I took a photograph of somebody from the front and from the side, and then went into Photoshop and kind of blended them. So it's this is the one that leaked, but it looks kind of like this. It's very odd looking photo. And the first time I did it, obviously the inkjet, I just laminated it, and I didn't get enough laminate in the mouth, and it all like kind of leaked in there. Now he's got a bloody nose, I guess. But yeah, in the tutorial, I'll show kind of how to put the picture together so that when you curve it, it looks like a 3-dimensional head.
Oh, that's really cool.
Yeah.
Well, thank you for coming by and showing that.
Yeah.
Let's see. Next up, I'm going to put on John Park.
Hey, Melissa.
Hey.
So I just wanted to show this cool thing that is an evolution of the Neo Trellis or Trellis driver board. So the original Trellis was a 4x4, which had elastomers that you would press, and then an LED. Second version had NeoPixels added to this, and my friend Steve, who goes by Denki Auto online, he's a friend of Adafruit, he came up with a version that used mechanical key switches. So you can see here, it's the familiar trellis design there, 4x4. He actually sells them as a 4-up that haven't been snapped apart yet, which is kind of nice. You could still snap these apart and rearrange them if you wanted to do different arrangement. But I did want just the 8x8. And then you can solder in either Kale chalk, which are these real low profile ones, or Cherry MX or low profile MX. And then use it for any of your light up-y kind of projects. So I'm going to do some sequencing with it, and a MIDI controller, maybe some other stuff. But I wanted to show that, and I may be working on a version of this using some of our existing components. But if people want to go check this out, I think he's sold out of them now. But I'll put some posts, some links in the show notes over on Discord if people want to check that out. So that is just a fun little thing that I'm glad he made. And the other thing I did was I 3D printed these keycaps, which I've been resistant to doing because that's kind of, I don't know, injection molding is so nice, but it's hard to find these low profile chalk keycaps, especially on short notice, and translucent ones. There's not that many of them. So it actually turned out really nicely printing these with a textured bed. So you get a little bit of that kind of frosting diffusion on there. So
oh yeah, that would work really good with like multi-material printing if you wanted to have any kind of like writing on those.
Yeah, I like that idea. I also like the idea of maybe just doing a window. Windowed keycaps are really hard to find and usually really expensive. So just doing the translucent material for a little dot or a square, and then doing the rest in an opaque material gives you a very nice and different look. So
yeah. And
I'll actually let me reset it, because when it starts up, I have a little boot sequence where it just shows off very brightly. Sorry, all of the LEDs, and then it's just tracking those. So that's the Mecha Trellis by Denki Auto, and he I'll post the GitHub too. You can make them yourself, I think, because he's posted the open source derivative files of those as well. So there you go.
Cool. Thank you for showing that off.
Sure thing.
Let's see. Next, I'm going to bring on Saleem. Hi.
Hey, thanks for having me on here. I'm super excited to show off my most recent project. I used to make things for about 10 years. My 3D printer was going constantly, and then a couple of years ago, a bunch of stuff happened. and I just kind of put it away. And this is my first project back, so I'm very excited. So I'm going to give you a little setup here. This is my vintage, old-timey, hand-cranked coffee grinder. Really love this thing. My parents had one when they were alive, and as a kid, I used to love grinding the coffee for them in the morning. And when I saw one of these pop up on eBay, I snagged it. It's cool. I mean, it's adjustable. You can do super coarse grind all the way to super fine grind. And if you're just doing like enough coffee for like 1 cup, it's perfect. You know, doesn't take that long. You can grind it. But if you're like me, I like to do like a pound of coffee at a time, because a pound is precisely how much my wife and I drink in about a week. So I just do kind of like a whole bag of coffee. Now, if you're doing a pound, this gets tiring because you're constantly feeding, cranking away, and it takes a while. It's a little bit of a heavy lift. So I thought, wouldn't it be great to kind of mechanize this? And so what I did, I'm going to take off the handle here. Okay, this screw's a little longer than I thought it was. Is I designed a 3D printable mount to turn this old-timey hand-cranked coffee grinder into a state-of-the-art KitchenAid stand mixer attachment. So here it is. Here's my mount. It's actually two 3D printed parts. You've got the inner shaft, and that shaft is the inner profile on that is actually designed to fit on this weird kind of shaped lobe. Just kind of goes on just like that to spin it. And then you've got the housing, which fits right on like that. And then I got some little things to tighten it down. And then I'm going to go ahead and mount it on my KitchenAid here so I can kind of show you how it looks. And I'm going to grab my camera and swing it around. So here we go. All set up. I used it this morning. I was actually printing this thing off late last night. This housing takes about 5 hours to print because it's very solid. It's the infill is about 80%, which basically is solid. Because I really wanted to show it off today. And this morning I did actually use it and ground a bag of coffee with it. Went pretty quickly, took about 6 or 7 minutes. It really kind of cranks away. So there is my my 3D printed KitchenAid stand mixer coffee grinder accessory.
That's pretty cool. Yeah, when you first were saying that you 3D printed something for that, I thought you were going to show like some kind of motorized attachment. And then when you said it was through the KitchenAid, I was like, that's a really good idea.
That was my first thought was, it was to like, mount this on like kind of a box-like structure with a motor underneath and a belt that would like attach it and crank that thing around. And then I'm like, wait a minute, KitchenAid makes this thing with the little accessory port on it. Why not just use that? I mean, the hardest part about this whole thing, I mean, this part was actually fairly easy. The hardest part was modeling this shape right here so that I could then, bring that in and have everything pair up. This thing, they originally designed these things back in like the 1800s. So, and it's all cast metal. So, the mold for this was probably kind of hand shaped. So none of the measurements anywhere on here are consistent. They're kind of all over the place. So, kind of modeling that out so that I could then fit this piece to it or, design a piece that would fit onto it. That was really the longest part. That probably took me a day to get enough measurements to get something, modeled up in Fusion 360. And then after that, pretty easy to then just, pair up something with it.
Yeah.
So, there you go.
Well, congrats on getting back into 3D printing.
Yeah, fun project.
And thanks for showing that off. And stopping by here. Let's see. Next, I am going to put on Cooper.
Hey
Hello.
there, Melissa. How are you doing?
Good. How are you?
Doing great. So I've been doing a lot of fruit jam work recently, and I was inspired by a lot of Scott's work on testing and stuff within Zephyr. Inspired so that I need to do some more testing too, because I found my workflow was very much so like jumping back forth between the fruit jam in order to make games and stuff. And that's kind of hard when you're like iterating small things over and over again. And so I thought, well, really, I knew that Blinka existed, but I didn't know that much about it, surprisingly enough. So I did a little bit of research, and I found this repository by Tim, Foamy Guy, which is
yeah.
Blinka Display IO Pi. It basically uses Pygame in order to generate a display output that's compatible with Display IO Blinka. So I started getting in the weeds and modifying my system in order to work with, basically be somewhat compatible with the Fruit Jam applications and Blinka. And so lo and behold, I'm going to do a little command that should pop up our game right on the desktop and native C, Python, etc. And I'm on a Mac OS here too, if that's any helpful. Now there's one thing missing. We talked about this before, show and tell here, which is audio. There currently isn't really that translation layer to do all the synth IO and audio mixer and so on that we have with CircuitPython. But we do have graphics, so that's a start. Anyway, so I thought I started, updating all my applications and stuff to be able to be compatible with this. And my hope is at some point to have a good system so that people that want to develop for the Fruit Jam and not just games, other applications, stuff like that, and want to quickly iterate on changes, that having this core to be able to execute them on your computer that you're working on without having to copy files back and forth or whatever you're doing. I thought that'd be pretty cool. One interesting thing is, surprisingly enough, I find that the actual microcontroller is a little bit faster for some of this stuff, just probably because we're in complete, Python land here rather than, native C and so on. Now, another end goal I have to this whole set of changes here is to hopefully, and correct me if I'm wrong here, Melissa, because you know more about Blinka than I do, but hopefully get this working with WebASM at some point. WASM, I don't know what you call it. Yeah.
WebAssembly,
yeah, WebAssembly. And because I have a few friends that I've talked about some of these games that we've made, and I've talked to them about, oh, it's really cool and it works on these little microcontrollers, and it's way over their head, right? And I would love to show some of them off, right? And what I think might be the solution there is to be able to have a online interface. I can just send them a link and then boom, it goes. Now, there's probably a lot of options out there to actually like rebuild the game, but
right,
awesome if it just worked, right? And I think that'd be helpful to other people, and so on. So my next goal after this is to look into the resources there. Now, I don't know if Blinka will work within WebAssembly at all. I have no idea, but I'm about to find out. And then next thing you know, you could have either a GitHub or itch.io hosted version of your Fruit Jam game or other application, whatever.
Okay.
Anyway, so that's kind of what I'm working on right now. So I figured I'd show.
So that the web interface could basically be the display instead of like Pygame?
It would use Pygame, actually. What I've looked into, there's some kind of connection there that I'm figuring out. But in theory, it should just be able to launch the application, and then using some kind of virtual machine within WebAssembly, be able to output its, the visual display. Yeah. So
yeah,
it's a little over my head right now, but I'll be diving into that next. Yeah.
Awesome. Well, thank you for showing that, and thank you for contributing to make Blinka and Blinka Display IO better.
Definitely. And honestly, I know I've been working within, native Mac OS-y kind of stuff, but I'm sure some of this could also work with, on Raspberry Pis and stuff like that. And hopefully the work I'm doing here will help people, output really cool video streams and stuff like that on the Raspberry Pi as well. Yeah.
Well, thank you for stopping by and showing that off.
Yeah. Thanks, Melissa. Thanks for letting me come by.
Yeah, thanks. And then lastly, I'm probably pronouncing this wrong, but it looks like Bradan Lane.
Yep.
And I'm not sure if they're there.
Yeah, hopefully you can hear me. Do you hear me or not?
I can hear you, yes.
Okay, cool. Thanks. Welcome and thank you for hosting tonight.
Thanks.
So I used to do these things called challenge coins or electronic challenge coins. And in them, they had story challenges that you'd read through, and then kind of like a Nancy Drew kind of story, which is kind of cool because that just got opened. That just opened the public domain this year. And you'd get to a point where you get stuck, and you'd have to solve a particular word problem or something else. And all the information you needed for that was provided in the text that you'd read up to that point. And there were short stories. And about 3 years ago, I really wanted to get into writing new text adventure games. So, Zork and Colossal Cave kind of things, but all new adventures. And they would use the same characters that I'd created for the story challenges. And I started looking at what kind of hardware. I needed USB because I wanted to, make it really easy for people to, plug into their computer. And so this is actually the form factor, and it's based off of the Itsy Bitsy M0. And I even got to the point of, it's got full CircuitPython support. So you can actually go to circuitpython.org and coin M0, and you will get the firmware for this. So that after you've played the text adventure game, you can flash it with CircuitPython, and you can do some very fun things. It's got touch sensors on it. It's got sound. It's got NeoPixel LEDs. And, this was the coin form factor. But I always wanted it to really be a coin. And so I started talking to an instructor at a high school engineering program. And we got talking about it, and he goes, well, I think our students could figure this out for you. And literally, they have been able to machine brass. And so they machine. So here's a blank that I've laser engraved, but they go through the process of actually machining this 2mm brass blank, and then I run it through a fiber laser to make all this artwork on it. And the only trick I had was I had to reduce all the electronics down to 2.8 millimeters tall, and that includes the PCB. But once I solved this problem, this literally fits into a pocket on there, and then a piece of our favorite, LED acrylic, like the black LED acrylic, and then it gets sandwiched between a brass back that I laser engrave and a brass front. And then the only thing I had to do was I couldn't use USB-C because it's too thick. And so I had to go back to the old micro USB connector. But literally it is a brass coin that plays a full text adventure game. You plug it into your computer and you can play. And I've got just a quick opening screen here. So just like a classic text adventure game, you get the sort of the startup screen, and it introduces you to, this one is Sarah and the Missing Artifacts. It takes place at a fictional research segment of the British Museum, and you get all the introductory text here. And then you start playing a text adventure game. You've got to find the artifacts. You've got to work your way through the museum, etc. And all of this is originally based off of the Itsy Bitsy M0. So, but what I wanted to make sure that, let me just jump back to the down camera. I wanted to make sure that once you'd played the text adventure game, if you wanted to do something else with it, this too runs CircuitPython. It doesn't have 3 touch sensors. It's got one really big one. So that whole brass plate becomes a touch sensor, and it's got NeoPixel LEDs on it, and it's got sound in it. And you can flash it with, whatever kind of CircuitPython type work. And like I said, it's if you go to circuitpython.org, it's coin M0. I did want to do something a little different though. So rather than try to sell these or take them to conferences and stuff, I launched what I call choose your own charity. So you go out to the website, you pick a charity that means something to you. You make a donation to it and just show me the receipt. I'll send you a coin. And so not only did I work with the school and I paid the school to generate the brass for me, but then also the choose your own charity is generating revenue for charities all over the United States. So that's my e-challenge coin for this year. And like I said, when it's all done, if you don't want to play the text adventure game a second time or a third time, you can flash it with CircuitPython too.
That's pretty cool. Thanks for showing that. It's also really cool that you're the donating to a charity of your choice to get the coin. Yeah, whole text adventure game. So is that done in Arduino or something for the game itself?
I did successfully write a text adventure game engine once in CircuitPython, but I kept running out of memory because of all the strings and all the data and stuff. So I've created my own game engine, and I use an online tool to create the map, and then I use a spreadsheet for laying out like all the objects you've got to find and what their values are and what rooms they're in, and if one object is dependent on another. And then I wrote this horribly long Python script that generates all the C code and all the data structures, and the stuff that has to be read-only versus read-write. It generates thousands of lines of data code, and then that just gets compiled into Arduino.
That's really cool. Yeah, that's a really good way, or a unique way of doing that. But
I needed to find a way to make the authoring of the game easier for me, because I was finding that I'd get all the hardware done, and then I couldn't bring myself to stay focused long enough to write all the software. And so now that I've got authoring tools that make it easy for me to create the game without thinking about code, now I actually enjoy writing these games. This particular text adventure game, Sarah and the Missing Artifacts, has 131 rooms, 34 artifacts. It's got various pitfalls you've got to solve. It's got security guards wandering around. It's got, elevators that require passcodes and key codes and stuff. I actually enjoyed playing the game, which I almost never do by the time I get to the game. By the time I get to the game, I'm usually kind of just done with it. But no, I've actually played the game a couple of times. I like it.
Cool. That's really good. It allows you to focus on the creative aspects that way.
Yeah, that's what I really wanted to do, is focus on, and I like the artwork. The working in brass was a really new experience for me. I just got a fiber laser this past year, and I've been pushing to learn how to really get coin-looking things. As a matter of fact, in this case, the font that's actually on the face of the coin is a reproduction of the font that's actually used by the British engravers that make the British coins. So I found somebody who had actually gone and they'd open sourced, their interpretation of that font. So it's the same font as you'd actually find on real British currency.
That's pretty cool. Anyway, I think we're about out of time here, but thank you for stopping by.
Thank you.
Well, that wraps it up for the show and tell for February 11th. And thank you for everybody who stopped by. There's some really good projects. And thank you for watching it.